In this video, we'll be going over the IUPAC naming conventions for organic compounds, which is a topic that can cause a lot of confusion for chemistry students. So lots of exam questions require you to either be able to name organic compounds or to be able to interpret the names of organic compounds in order to answer a question maybe about like empirical formula, or maybe it's a organic reaction you have to work out or something like that. So being able to recognize and name these compounds is a really important skill in our study of organic chemistry. So we're going to look at all the naming conventions you're going to need to know in order to name any organic compound that you'll see in Year 12 chemistry with the aid of some worked examples. So the IUPAC naming system came about in 1919 as a way to standardize names of organic compounds. So obviously these compounds are quite big, so it's good to have a nice and concise and logical name for them. The good thing about IUPAC naming conventions is that there's a unique name for every single organic compound you'll come across, which gets rid of a lot of the confusion that can arise when dealing with organic compound names. As for naming organic compounds, the best scenario is when you only have one functional group, like the examples that we see here. So when we're dealing with these, first thing we want to be doing is identify the root of the carbon chain, or that is, what's the longest chain of continuous carbons that we can find. Then we need to find whatever functional group we have and have a look at its corresponding suffix, which should be in some sort of table that you're given, but you can also memorize them all quite easily. So all we need to do is add the position of where this functional group is, along with the suffix that represents the name of the carbon chain, and then we're pretty much done. So let's have a look at some of these examples. So in this example right here, we can see an alcohol functional group down here, and that's all that we have here. Now, if we have a look at the length of the carbon chain, we've got one carbon here, one carbon here, one carbon here, and one carbon here. That's 4 in total. Now we can see that the alcohol is in position 2 here, right? Now notice how if I started numbering this compound in reverse, so started with 4 here, then 3, then 2, then 1, then the alcohol would be in the 3rd position. But usually we just take whatever position is the lowest possible number that we can. So now that we've identified that, we all have all the information we need to identify the compound. So since we have 4 carbons here, we know that the suffix is going to be butanol. So we can put a butane there. We also know that since it's an alcohol, we need to have an ol at the end, and it's in position 2. So when we put that all together, we'll arrive at the answer 2-butanol. All right, let's have a look at the second example. So in this one, first we're going to identify our carbon chain. We can see we have 1, 2, 3 carbons in a line here. So I'll write that down here. We also see that we have a functional amine group here. That's nitrogen and 2 hydrogens attached to it. We also see that this amine is at position 1 of the compound, and this is all the information we need to name the compound. So our stem, because we've got 3 carbons, is going to be propane. We've got an amine, which has a suffix amine, and it's in position 1. So that should suggest the name 1-propylamine. So sometimes we might have more than one functional group that appears, but this is not usually much of a problem because we can add the prefix that we normally use for naming alkanes and other kinds of functional groups that we've looked at in Year 11 chemistry. So let's have a look at some of these compounds here. This one should be familiar from Year 11 chemistry. Let's identify the carbon chain. So it's important with examples like these to be very careful when you look for your carbon chain, because sometimes it's not usually obvious which one the carbon chain is. In this case, we know that if we draw a line here, we've got 1, 2, 3, 4, 5. That's 5 carbons lined up. That's the best we can get. Now, if we have a look for our functional groups, we can see 2 different alkane groups over here. So we've got 1 over here and 1 over here. Now, there's 1 carbon in each of these alkane groups, so we'd call these both methyl groups. So in total we have 2 methyl groups, so we would have dimethyl at the start. And we know that since we have 5 carbons, our stem is going to be pentane. So when we put that all together, we're going to end up with 2, 4, because those are the positions of the methyls, dimethyl propane. So write that down, 2, 4, oops, dimethyl propane. Okay, this one's a bit of a harder example. We've got this skeleton diagram notation, which is sometimes used to kind of trick students. All we really need to be aware of here is that each of these kind of corners of the graph represent 1 carbon atom. So there'd be a carbon here, there'd be a carbon here, and there'd be a carbon here. So that means we've got 3 carbons in total in this chain. So again, we're going to have the suffix of propane. And now we see 2 functional alkane groups here. So we've got 1 over here, and we've got 1 over here. So these alcohols are in positions 1 and 2, and they have the suffix ol. And we have 2 of them, so we're again going to have the prefix di in front of that. So we put that all together, we end up with 1, 2 dipropanol. Alright, so where it starts to get tricky is when we have multiple different function groups and we've got to kind of distinguish between them. Now this isn't as simple as the case we've looked at before, because we need to follow a kind of hierarchy as to what functional groups take priority. So I've got a table here listed for what are the most important functional groups, which you can memorize, but I think a better way of thinking of it is the functional groups with the highest priority kind of have the most impact on the chemical properties of the compound. So for example, the most important functional group is a carboxyl group, that is a COOH at the end of it. That tells us that it's going to be an acid, like ethanoic acid, methanoic acid, those sorts of acids. Obviously, acids have lots of different chemical properties, whereas one of the lowest ones would be like a halogen group or something. If you slap like a chlorine on the end of a very long alkane like propane or something, probably not going to do too much to impact its chemical properties that much. So you can use that as a general guide. So normally the strategy for solving problems like these is to first identify which one is the highest priority functional group, and then look at the other functional groups and put them before the main chain and added functional group kind of structure that we've seen before. So let's have a look at that with this example right here. So we've got 2 functional groups. We've got an alcohol at the back. We've got an amine up here. If we look at our chart thing, we can see amines are over here, alcohols are up here. So alcohols are more important than amines. So since alcohols are more important, we'll be using the alcohol suffix because they're the top priority group. So again, we're using the suffix ol. And since our amine group is not the most important priority group, then we're going to be using the prefix. So in this case, amino. Next, we'll have a look at our carbon chain. So we have 1, 2, 3 carbons in our carbon chain like before. So that's going to give us the overall stem of propane again. So let's put that all together. We've got 1 amino and it's in position 2. It's the least important functional group, so it's going to go at the start. So we're going to have 2 amino. We've got 1 alcohol and it's in position 1. So we're going to put that at the front, 1 propanol. And that would be the name of this organic compound. So I hope this video has helped to demystify some of the IUPAC naming conventions and help you with your study in organic chemistry in the future. Thank you for watching. My name is Henry, part of a team at Elucidate, a non-profit organisation that helps young people succeed at school. If you would like to see more chemistry videos, click up here. If you would like to learn more about us or support us, click down here.